So yesterday we talked about the exponential equations and the characteristics of exponential functions. And we said that an exponential function looks like what?
Flat on one side and gets
Decreasing
bigger,
or
increases or decreases quickly.
Okay, so flat on one side increases or decreases quickly, and that would be the graph of it. How would the equation look like? What's special about its equation? To the power of x. So the variable is your exponent, or your exponent is the variable. So the general form is y equals, now for this one, it's supposed to be b to the power of x, but I'm going to use right away the actual one that I want you to use, okay? I'm not going to teach you a simpler one and then the harder one. I'm just going to right away start with the actual equation. So y equals a to the power of x. Okay? Where b represents your growth or decay factor. It's either growth or decay factor. Now a represents, decay means decrease. A represents the initial value. Most of the time, your initial value, or not most of the time, sometimes your initial value is 1, right? And then if this is 1, then it just becomes y equals b to the power of x. So the simpler one is y equals b to the power of x. But if your a is other than 1, then you have to include that a. We're going to look at examples like this. So, we're going to look at the two types of exponential relations in the chart below, and then we're going to compare them. So if you look at the first chart, if I'm starting from the negative x and going toward the positive x, what do we see? Is it increasing or is it decreasing? Increasing. So we always move from left to right. Okay, we always move from the negative x values to the positive x values to look at my trend. Okay. So moving, I keep writing infinity instead of x. So moving from the negative x to the positive x, we see that our graph is flat on one side, but then increasing fast after. Right? You see that? So that's what we call an exponential growth. All right? Now, for this one, the negative x value to the positive x value, what do you see? So moving from the negative x value to the positive x value, what do you see here? Decreasing fast and then flattening out, right? Becoming flat. So this is what we call an exponential decay, okay, because it's decreasing. All right? So exponential growth, exponential decay. So the exponent, for example, the equation for this exponential growth is y equals 2 to the power of x. Okay? What's the base for this equation? 2. So 2 is greater than 1, correct?
Yes.
So when your base is greater than 1, the relation is exponential growth. So when you look at the equation, whatever the equation is, if y equals 1.57 to the power of x, right? Your base here is greater than 1. That means it's an exponential growth, right? So you always look at your base, and then if your base is greater than 1, then we know it's an exponential growth. Okay? And then as we can see, because the graph moves up to the right, so it's moving up and increasing fast as we go from the negative x to the positive x. How about for the exponential decay? So when the base b is between 0 and 1, then it's going to be an exponential decay. What's your base for this equation? 0.5. And 0.5 is between the numbers 0 and 1. Right? So that's how I know it's an exponential decay. Give me another example with an exponential decay. 0.4. Sure.
0.25.
Sure. Right? These are exponential decays, as long as it's 0 point something. It could be a fraction, as long as the fraction could be either positive or negative, not positive. It could be bigger than 1 or less than 1. As long as your fraction is, let's say, 2 over 3, right? That gives you 0.6, right? Which means it's between 0 and 1.
So the fraction.
The fraction, I mean, this is a fraction. But is this fraction bigger than 1 or between 0 and 1? Bigger than 1. So that's an exponential growth or exponential decay? Growth. Right?
Will they ever be negative?
No. No. Your basis has to always be positive. Okay? So the value of b is considered what we call the growth rate in the case of the growth. And in the decay, we call it the decay factor. Sorry, not rate. Factor. Growth factor or decay factor. So when I ask you what is your growth factor or what's your decay factor, you should be able to say, well, your growth factor in this equation is 2. Your growth factor in this equation is 0.5. Okay? The next question is asking you what is the x value, or what's the x-intercept? What will the x-intercept be? So to find the x-intercept, I'm going to have to let y equals to what? 0. So let's use the first equation, y equals 2 to the power of x. Okay. If I have y equals to 0, 0 equals 2 to the power of x. Because I have to let y equals to 0. Okay? Now, give me a value for x that would make it 0. Nothing? Let's try. Give me a value for x. 2. What's 2 to the power of 2? So it's not 0. Give me another value for x.
0.
0 to the power of 0 is 1. Give me another value. So we can't do that. If I do 2 to the power of 0, right? 2 to the power of 0 is 1. So, and then anything above 0, it's going to become bigger and bigger, right? So give me numbers below 0.
Negative
1.
So 2 to the power of negative 1, what is that?
It's 2 to the power of negative 2.
What's 2 to the power of negative 2?
What have you created?
What's 2 to the power of negative 2?
0.
No.
0.
Try it. 2 to the power of negative 2.
0.25.
0.25. What's 2 to the power of negative 10? You have a calculator, don't you?
What the heck? 9.76?
No, times 10 to the power of what?
Oh.
My calculator doesn't do
Do 2 to the power of negative 10.
Became over. So we
Can I see it? If it's 9.76 times 10 to the power of negative 4. So that's 0.000976. So when your calculator gives you something like this, and then you see that, right? It's important to know what you're reading. Okay, eyes on me, please. That means you're going to have to move the decimal 4 units to the left, okay? Because it's 10 to the power of negative 4, okay? So eyes on me. That actually means, so if I have this number, and I'm going to have to move that decimal 4 to the left. 1, 2, 3, 4, right? So that's 0.0009766. Okay? This number is not 9.7. It's 0.0009766. Because the calculator is a scientific calculator, and scientific notation is this.
I can't put numbers to the power of something. Like I have to do something. I have to like times it by 12. Like when I click this, it's
this. So 2 to the power of negative 10. Oops. Your answer here is given as 0.
oh, so that's what that thing is right
Yep. So is this number 0 or no? Is it 0?
there? No.
It's not 0.
I thought it never touched 0.
Exactly. It will
I
never
thought
touch
that was, like,
0.
a trick
Oh, it's
question.
okay.
It will never touch 0. So I don't have an x-intercept.
So technically it's no zeros. There's no zeros in the
There's no x-intercept. Unless later, if you take any other courses later on, and then you're looking for transformation, then it touches. But in the case of just this, there's no transformation. So it will never have an x-intercept. No x-intercept. It's never going to equal to zero. Okay? So that means I don't have, it's going to approach the 0, but will never get to 0. Okay? So I don't have any x-intercept. Does that make sense to you guys?
So I should put there will never be an x-intercept.
Yeah. How about for the y-intercept? What do I plug in for x?
1.
What do I plug in for x for the y-intercept?
0.
0. If you look at any time you're intersecting, right? If you're intersecting the y, if your graph is intersecting the y, that means the x value is 0. If you're intersecting the x, that means your y value is 0. It's always that. That's always the case. No matter what kind of function you have, if you're intersecting the x, y is 0. If you're intersecting the y, x is 0. So, if I plug in, so my equation is y equals 2 to the power of x. If I plug in 0 for x, what would be my y-intercept? What's my y-intercept? 1. Okay? Even for my other question, which is the 0.5 to the power of x, if I plug in 0 for x, that equals to 1 as well. Okay? So my y-intercept for both cases is 1. So if I go back here, my y-intercept, which is, this is my y-intercept, and it's 1. And my y-intercept here is here, and then it's 1 for both. Are we okay with that? Here's the table of values to answer the questions below. So I give you a table of value, x and y, and I ask you to find the first ratio. What do you do when you're finding first ratio?
Divide.
Divide what by what?
Y2 divided
So
by
y2 divided by
Y1.
y1. So 3 divided by 1.
3.
9 divided by 3.
3,
27 divided by 9.
3,
81 divided by 27.
3, 3. And
Is the relationship exponential?
yes,
And how do you know that?
the first ratio is constant.
So what would be your exponential equation? So let's start, because it's exponential, let's write the general form. What's the general form?
A, B,
Y equals
oh,
A
B,
B
raised to X.
to the power of X. What's my initial A value? So look at your initial value. For initial is always you're looking at X equals 0, right? What's your initial value at X equals 0? 1. So that means Y is 1. Okay? So that's going to be 1. What's your base?
3,
3. Because the base is my first ratio to the power of X. So do I need to have that 1 here? No. If it's written or not written, it's like when you have 1x squared or just x squared. It's the same thing. 1 times 3 to the power of x is the same thing as just 3 to the power of x. Okay? So I can write this as y equals 3 to the power of x. That's my equation for this relationship. Are we okay with that? Do we know where we got the a from? That's where x is 0, y is 1. That's my initial. Always you look at x is 0 for your initial. Okay? So let's say if this was, let's say 10, right? Then your initial is going to be 10. Okay? And then your base is the same thing as your first ratio. We talked about that yesterday.
The ratio of the base.
Okay? So if I'm going to graph this, so because my numbers are a bit tricky, I'm going to go up by 5. Or maybe I can go up by 2. Let's go up by 2. Can I go up by 2, do you think?
5,
2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I think the biggest number I have is what? Oh, 81. So yeah, let's go up by 5. 5, 10, 15, 20, 25, 30, 35. Still not enough. 40, that's okay. I don't have to include the last point. Okay, 1, 2, 3, 4, 5, 6. So for x is 0, y was 1. So right here. X is 2, x is 1, y is 3. X is 2, y is 9, was it? X is 2, y is 9. X is 3, y was 27. And x is 4, y is 81, so that's way off the chart. Okay, what do you see here? You see this, right? And then on this side, technically, it's going to be flat, and we see the increase
So, means-
passing.
so even though I just print this out, it's still gonna be an
Yeah.
exponential growth.
Are we okay with this? Okay. Let's look at this example. A small garden center propagates tulip bulbs. The gardener begins with 100 bulbs. Each bulb produces several new bulbs. 3 of these are kept for the next round. So each bulb is going to produce how many bulbs? 3, right? Because they're going to produce more than 3, but we're only going to keep 3 for each one. Okay? So each one bulb we're going to keep 3 from. Okay? Write an equation to represent the number of new bulbs. So what am I starting with here? 100. Are we starting with 100 bulbs? Yes, right? Because if you look at this, the gardener begins with 100 bulbs. What do we call that? The initial value. So before we started with 100. Okay? So where do I put that?
The A.
For my round 0, right? For round 0, I already have 100 bulbs. Okay? What's going to happen after my first round? How many bulbs do you think I'm going to have after my first round? 300. And how do you know that?
100 times 3.
Each bulb is going to give you 3, so you're going to do 100 times 3, right?
And then 300 times.
On the second round, now I have 300. And then 300, each one is going to produce 3. So it's going to be 300 times 3. But I'm going to write it this way just because I want you to see something after. So I'm going to take the 100 times 3, and then I'm going to multiply it by 3. Okay? So this part is coming from this part. Okay? Now, what happens in the next round?
Oh wait. 900 times 3.
So now for this one, that's going to be 900. Okay? Now for the next round, it's going to be 900 times 3. But if I'm going to use this part, then it's going to be 100 times 3 times 3 from the previous one, and then times another 3, right? Okay. Now there's a reason I'm showing you this. What's my initial value?
0.
100. And then what's happening to my numbers? Tripling. So what's my base, do you think? 3, right? Because if I do my ratio is going to be, if I do 300 divided by 100, that's going to be 3. 900 divided by 300, that's going to be 3. So my ratio is going to be 3 because it's tripling, right? So if I'm going to use that y equals ab to the power of x, what's my a? What's my base? And then if I have n rounds, it's going to be 3 to the power of n, right? Because it's telling me n rounds, right? So if you look here, guys, I'm just going to write this. Look at me. So I have 100 and then 3. How many times do you have the 3? So that's 3 to the power of 3, no? How about for this one? What would it be? 100 times 3 to the power of 2. How about this one? 100 times 3 to the power of 1, right? So you see the number of rounds? That's what's going on as your exponent. That's your exponent. That's the number of rounds, right? So if I'm going to ask you right now, how many bulbs would you have after 20 rounds? What would you do? So n is equal to 20, and then you can do 100 times 3 to the power of 20, right? You don't even have to do all the table of value all the way to 20, because you know your equation. So what did we say the initial number of bulbs is?
100.
And then you're going to multiply by the growth factor for each round, which is
3.
3.
Everything is
So we've already solved most of this. So the generalization, exponential growth, and decay is what? Y equals a b to the power of x. And that's why I started you right away with the y equals a b to the power of x, because I know we're going to get to it. Okay? A is,
100.
what does it represent?
The initial value.
B is the base, but it's your growth or decay factor, right? Or in other words, it's your common ratio. Y is the value after x periods of exponential growth. So how many do you have, how many bulbs do you have after 10 rounds? Or how many bulbs do you have after 15 rounds, or whatever it is? So we said that the equation is, for this question above, y equals 100
3.
Bracket 3 to the power of
3.
x or n or whatever it is. It's easy if I grow or my decay factor, okay? So if I know that it's tripling, or I know that it's doubling, or I know it's halving, it's easy. But in the scenario that they give me a percentage, I have to use a different formula. It's the same formula, but a little bit different. So the formula when you are given percentage, let me just add a page here. So when they give you a rate, which is a percent, okay, you're going to have to use one of these two formulas. The formula is y equal a1 plus your rate to the power of x, and that's for your growth. And for the decay, it will be y equals a1 minus I to the power of x. The reason why we call this the growth is because 1 plus a rate, that gives you a number that's greater than 1.
that's a
I. And then 1 minus a rate, that will give you a number less than 1. We'll talk about that in a second. What does A represent? In both equations, A represents your initial value. Your I
Is the growth or decay factor?
is your rate. Okay? So it's the rate that they give you in percent. So you're going to have to ask yourself, are my numbers going to be growing? Do I have a growth or do I have a decay? Then you can pick one of these two formulas. I should always be in decimal. So the rate, if they give you, let's say, 5%, right? You're going to have to plug it in as
0.5.
0.05. Because 5%, if you divide it by 100, it gives you 0.05. So your I has to always be in decimal, not in percent. let's look back at that example. Okay? So, suppose you have $500 in the bank. And you deposit it into a savings account that pays 2% interest per year. Find the equation that models this exponential growth. So since they give me a rate, a percent, then what formula do I have to use?
Gross.
Which one? The one that I just talked about, right? On this page, right? So I have to use a plus. So y equals a1 plus I to the power of x. Now some formulas, eyes on me for a second, they could use a for y, p for a, 1 plus I to the power of n. Guess what? If it's looking like this or like this, they're the same thing. They just use different letters. P is their principal, A is their amount. It's still, the letters don't make any difference as long as the position where they are, that's what makes a difference. So, A represents the initial. What's my initial amount that I'm putting in?
500.
So that 500 represents the A, right? What's the 2%? The I. But do I write it as 2%?
No.
What do I write as?
0.02.
0.02. So let's plug it in. Y equals 500, 1 plus 0.02 to the power of x. Is there anything that I can simplify?
1 plus 0.02.
Which is what?
1.0.
1.02. Now, look at my base. Is my base greater than 1?
Yes.
Yes, right? So that's what makes it an exponential growth, because I'm adding 1 plus the 0.02. Okay? So you look at the base, and then your base should be greater than 1. Now, is this the equation that models my scenario? Is this an equation?
Yes.
Y, X, right? Okay. Find the amount of money you will have after 3 years. What do you do?
Do you plug the 3 in where the x is?
Correct. Because this is how many years you're gonna put your amount into in the bank, right? So you have to do y equals 500, 1.02 to the power of 3. Do that in the calculator. 530. 0.6.
104.
So repeat the answer. 500.
30.
Uh-huh.
604.
The money has to only be to 2 decimal place, so that's going to be 60, right? Always leave money to 2 decimal places. And make sure you round properly.
So basically, x is time.
Sorry?
X is time.
X is time, that's right. So since this is a word problem, what do I have to leave my word problem with? There's a therefore statement. Therefore,
The money you will have in 3 years.
there will be 530.6 dollars in the bank after 3 years. Does that make sense to you? Did it grow? Did my money grow? It did.
A little bit. $30.
they're only giving you 2%.
What's the Bitcoin?
They're only giving you 2%, right, per year. So you're gonna have different kinds of questions. You're gonna have to decide, do I know my ratio? Do I know right away my common ratio? And if I do, then I can use it as my base. But in questions where they give you something like this, you're gonna have to pick one of these two formulas to solve.